Hey guys, so yesterday we talked about alkanes. Um, we looked at how this is sort of like a general formula for alkanes, which composed of carbon single bonded to other carbons, which are also bonded to hydrogens. Um, we looked at the basic nomenclature of alkane, like one carbon will be meth, and since this is an alkane, the ending would be ane. So CH4 is methane. Okay, if you have three carbon in an alkane, that will be prop, and that leads to the name propane. And then we looked at, of course, different types of formulas, like chemical formulas, C4H10, for example. Um, we said this, I'm not sure if I mentioned it, but this is actually pretty useless. Now we'll talk about that today, why I would say that. This is actually useless, this is useless. These are good. These are actually fine. But why would these be not very useful? Now, on the verge of talking about chemical formulas, this is called structural formula. Some people even call it skeletal formula, where you have the carbon chained up in covalent bond, and making sure that each carbon has four bonds. Okay, uh, the formula that I'm interested in, and I hope all of you get used to looking at, of course, is the condensed formula. All right, this is indicating what each carbon is bonded to. All right, so let's focus on this guy. Why did I say C4H10 is useless? Okay, well, let me just tell you right now. Oh, let me just show you actually. C4H10. This is C4H10. We drew this yesterday. We all agree that this is C4H10. Everything looks great. Okay, all the carbon has four bonds. All the hydrogen has one bond like they're supposed to. And we even named it butane. But that's not really the name for this compound. The real name for this compound is actually called N-butane. Now, N stands for straight chain. Does that mean there's something else here that won't be a straight chain? Okay, check this out. I'm going to draw C4H10 again, but it will look a little different. Watch this. I'm going to have carbon bonded to carbon, bonded to carbon. But I'm not going to bond another carbon here. No. I'm not going to do that. I'm going to bond the fourth carbon down here. Now, automatically, you know this is going to look different. But does it make sense? Is this still C4H10? Hey, let's put in the hydrogen. For this carbon, I owe 3 hydrogen. Because remember, carbon always make 4 bonds. For this carbon, I owe 1 hydrogen. For this one, 3 hydrogen. For this one, also 3 hydrogen. So if you count, okay, that's C4. Is it H10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my goodness, this is still C4H10, but this looks completely different than this. And I can tell you right now, this is not butane. You won't even call this butane. These two guys have different boiling point, different melting point, different density. They are different. They react differently. They react with different things. The question is, how do you name this guy? Now, this is, I guess, the harder part about for organic chemistry is how to name complicated structure like this. Now we know why this is butane, because it's 4 carbon linked one by one. Okay, one carbon linked to another carbon to another carbon to another carbon in a straight chain. But here, that's not really the case. So there's some naming method here. And let's write this down. Okay. This is the method of naming alkane. So number 1, locate the longest carbon-carbon chain. Okay, so in this case, this is your largest carbon-carbon chain, longest carbon-carbon chain, which is composed of 3 carbon. Now, you may be asking, does it always have to be straight? No, the answer is no, it doesn't have to be straight. You just have to make sure that carbon connected to carbon connected to carbon until there's no more carbon to connect, which means it can be like this. That's fine. Or it can be like this. That's okay too. You'll end up with the same name at the end. So let's just look at it like this. All right, much easier to look at. Number 2, assign number. Assign consecutive number to the carbons. Okay, you can go from left to right or right to left. It really doesn't matter in this case, because making sure the side group receive the lower number. Okay, now what are side group? This is a side group because that's not part of the longest chain. So we're going to assign number to these carbon, making sure that this guy inherit the lower carbon number where it stemmed from. Now, to do this, we will say this is carbon number 1, this is carbon number 2, this is carbon number 3. Now, does it matter if I'm going left to right or right to left? No, because if you go from left to right, like we have right here, this side group is stemming from carbon number 2. See, the side group is coming up from carbon number 2. Now, if I were to number it the other way, 1, 2, 3, oh my goodness, the side group is still stemming from carbon number 2. So in this case, it doesn't matter if you're going from left to right or right to left. But later on, I will show you an example where it does matter. All right, so let's take a look at step number 3. Okay, after locating the longest carbon-carbon chain, after assigning numbers where the side group gets the lower number, we get to name it. Okay, but naming it takes a little bit of skill. Okay, how do you name it? First, name and locate side group with YL ending. Okay, I'll show you exactly what I mean later. And then name the longest chain. Okay, the trick here, of course, is the name, locate, and the longest chain. How are we going to do that? what is this guy's name? Now, I'm going to tell you his name very quickly, and then we're going to dissect exactly why this name is as is. Okay, this guy right here, this dude, is called 2-methyl propane. Now, this is actually too much information. Most people just call it methylpropane. They might even call that. They may even call it isopropane. But it doesn't matter. We're studying IUPAC naming, and IUPAC state that this is methylpropane, or 2-methylpropane. Now, let's take a look at where this name came from. Okay? 2-methyl. Why 2-methyl? Well, it's very simple. When you think about it, okay, it's 2-methyl because the 1 carbon side group, okay, is at the number 2 position of the longest chain. Meth means 1. Meth means there's 1 carbon. Thyl means this is a side group, and it's stemming from carbon number 2. So that's why we call it 2-methyl. Now, why propane and not butane? It's because the longest chain is only 3 carbon. Just like what we said in the description. You want to name and locate the side group. So we did. We name and locate the side group. And then name the longest chain, which we did. The longest chain is a 3-carbon alkane, which we call propane. Get it? Now, since both of these, okay, N-butane and 2-methylpropane shares the same chemical formula, we call these two guys isomers. Now, because they differ structurally, we call them structural isomers. Okay? Structural isomers that you've seen before, like glucose and fructose. Oh, I wonder where you've seen those. Thus, structural isomer, because glucose has a hexagonic structure, okay, and fructose has a pentagonic structure. They're both C6H12O6, but as you can see, they differ structurally. Okay, I hope you've seen these before. I know you did. Oh, you better say you do when somebody asks you. Anyway, that's C4H10. Okay, there's the straight chain version called butane, and there's what we call the branch chain version called 2-methylpropane. Okay, so let's move on. Let's do another one, because the idea of isomerism is actually very, very important and very interesting too. So let's do this one. C5H12. Okay, and let me just show you very quickly that this is the most obvious case. This is the most obvious, C5H12. Okay, since this is a straight chain, there's really no need to locate it and assign number to it. You can automatically name it pentane. But can I just say pentane? The answer is no, you can't just say pentane. But even though when you say pentane, people know what you're talking about, but theoretically you should say N-pentane. Alright? But Is pentane the only C5H12? No, I wish. I could do a 4-carbon chain. Okay? And I can have the 5th carbon coming from the 2nd carbon. If I fill it up with hydrogen, I will know that, oh, this is also C5H12. Okay, well, let me draw some condensed formula for you too. So for N-pentane, I will have CH3, CH2, 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 CH3. Okay, for this guy right here, let me draw its structural formula. So I will have CH3, CH, CH2, CH3. And then coming down from here, I have another CH3. That's how you would do a branch condensed formula. Okay, showing the branching from this carbon. All right, naming time. All right, so how are we going to name this? Remember the rule. Rule number 1, find your longest carbon-carbon chain. Well, this is your longest carbon-carbon chain. It consists of 4 carbon. Now remember what I said. It doesn't have to be straight. This can be done also. As long as carbon connected to carbon, connected to carbon, connected to carbon, it can be your longest chain, or at least potentially can be your longest chain. Obviously this won't be it because that's only 3 carbon. Okay, so your best bet, of course, is either this or this. Now you'll know it won't matter. Trust me, you know it won't matter at the end. So let's locate the longest chain right here. Longest carbon-carbon chain. Now the question is, who is carbon number 1? Should I go clockwise? Or should I go counterclockwise? Sorry, clockwise. Left to right or right to left? I would say, or I think you would know, it should be left to right. Why? Because if you remember the rule, you want to make sure that your side group is stemming off from a lower carbon number. Hey, 2 is better than 3. If you go the other way, this will be 1, 2, 3, 4. Okay, you don't want 3 here, you want 2. So therefore, numbering from left to right will give you the side group to be 2. Right? Hopefully that you understand that. So let's name this. This guy's a side group. Okay, and this side group is coming from carbon number 2. So we say 2 is a 1 carbon side group. So 1 means meth, and it's a side group, so we say 2-methyl. Not 2-methane, but methyl. Dash, we usually put dashes. Some textbooks just put a space. Some just don't even dash, don't even space. They just straight up, okay, all letters and numbers without any space. But as long as you understand where it's coming from, you should be good. Now, we took care of the side group. This is 2-methyl, so your longest chain is going to be a butane. Alright, so N-pentane and 2-methylbutane are cousins. Sorry, they're isomers, like cousins of C5H12. Now. Is there another C5H12? Can we draw another C5H12? You may be thinking, I purposely drew the side group coming from number 2. Can I draw a side group coming from number 3? like this, like that. I'm not drawing the hydrogen because it's too much work, but you get the idea. Can I say, hey, this is 1, 2, 3, 4, 3 methyl butane, right? No. No, 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 no. Why not? Because, yes, this is your potential longest chain, but nobody said you can't number it backwards, because when you number it backwards, this carbon right here is stemming from number 2. This is still 2-methyl butane. This and this is the same, right? It's the same Pokemon. You already caught this Pokemon. Why would you want to catch it again? You already caught it. So no. No 3-methylbutane. 3-methylbutane doesn't exist because if you were to number it backwards, it's still 2-methylbutane. No 3-methylbutane. All right? Keep that in mind. Okay? Because on a test, if you draw these 3, I will only mark 2 of them being right because this right here was a double of this one. So the questions still remain. Is there another C5H12? The answer is yes, there is. Check this out. I like green. 3 carbon. 1 going from down there, 1 up here. If you count all the hydrogen that I'm going to draw, it is equal to 12. This is C5H12. This is an isomer. Cool, huh? This is your longest chain. Okay, or going up, or doing one of these. Okay, it doesn't matter. Okay, there's your longest chain. Doesn't matter how you number it, left to right or right to left, because they are going to be the same. Let's say left to right. We like to read from left to right, which makes this and this side group. Oh, look like there's 2 side group, and they're both 1 carbon each. They're both 1 carbon each. Okay, this is 1 carbon, this is 1 carbon. Both connected to carbon 2. So how would you name something like that? Very simple. Okay? Nothing fancy. You say at position number 2 and at position number 2. We're talking about this guy and this guy. They're both connected to number 2. There are 2 methyl group. Okay, there's 2 methyl group. So the word di means 2. So 2 times 1 carbon group. Methyl means 1 carbon group. Dimethyl means 2 of these 1 carbon group, which is so true. How would I end this? What is the longest chain? Is it a pentane? No. Is it a butane? No. It's a propane. Wow. Okay, let's do a condensed one quick. Now, one more example for you. Enough. One for you to do for homework. So, CH3, C, CH3, one coming down here, one going up here. There you go. Okay. So, pretty neat. This C5H12 has 3 isomers. Okay, so N-pentane, 2-methylbutane, and 2,2-dimethylpropane are all part of C5H12 family. That's why I said C5H12 is very useless. Because when you say, hey, can I get some C5H12? Somebody with the right mind, knowing about isomerism, will ask you back, which C5H12 do you want? I have N-pentane, I have 2-methylbutane, I have 2,2-dimethylpropane. They're all C5H12. Which one do you want? Right? It's almost like saying, oh, Emily's my best friend. Ooh, which Emily are you talking about? There are too many. All right. Let's do another question. Oh, before we do that, let's do another. Let's go back to C5H12. You may be thinking, okay, here's, oh, not this one. Like this. Why can't I do this? Right? Why can't I do this? Okay, 1, 2, 3, 4. 1 methyl butane. Can I do that? No, you cannot do that. That's ridiculous. Why can you not do that? Well, remember picking the longest chain, step 1. This is your longest chain. Okay, this is just N-pentane. You would number like this too, if you want to number it. So no such thing. So when you're assigning psi groups, don't assign it at position number 1. That makes no sense. Okay. All right. Let's continue. Let's do one more example. Okay, so we'll do C6H14. All right. Because I want you guys to learn about condensed formula, I will only do condensed formula for this example. Hopefully you can catch on. Just remember, carbon always bonds with 4 things. Okay? Let's take a look at how many isomers C6H14 has. How many cousin does it contain? Okay? Well, hey, I have this one. Okay. Oh, watch this. I can put H's like that. Look at that. CH2, 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 CH3. There you go. How do you name this? I call this N-hexane because it's 6 and because it's a straight chain. Do I need to assign number? Why would I do that? Is there another one? Of course there is. Let's put some side chain onto this. CH3, CH, that's it. Okay. CH2, because I'm going to put a side chain right here. This C is connected to this C, or they connected to this C. It's connected to this H, so I can connect one more thing, and that would be a CH3 later on. CH2, CH3. So that's 1, 2, 3, 4, 5. One more carbon. I specifically left the room right here for this carbon, CH3, to come over. There you go. That's a side. That's another C6H12. This will be my psi group. This is my longest chain. Would I number it left to right or right to left? Well, again, if I name it left to right, my psi group inherits number 2. If I go from right to left, my psi group is number 4. 2 versus 4. Which one is better? Of course, 2. Okay. So this side group right here is in position number 2. Let's not put this there. So, do you remember how to name this? Name the position where the side group is and what that side group is. So is at position number 2 is a 1 carbon side group. This longest chain is a pentane. Okay. Is there another isomer, do you think, for C6H12? Bet there is, because I can right now move that side group to the carbon 3 position, like this. Making sure that this is a CH, okay, not a CH2. Because this carbon is bonded to this carbon, this hydrogen, and this carbon. That's 4. Okay, if you put a 2 here, you're telling me that this carbon can bond 5 things? I don't think so. All right. So, there's my longest chain. For this case, doesn't matter left to right or right to left? No, it doesn't. Because both ways you'll get your side group at position number 3. So this is called 3-methyl pentane. Okay. Oh, so I went from position 2 to position 3. Oh, okay. I know. I'm gonna do position 4. Right there, 4-methyl pentane. Right? No, it's not. Yeah, this is your longest chain, but if I were to number it backwards, hey, this guy's in position number 2. This should be 2-methyl pentane. I already have that. Okay, I already got this Pokemon. I don't need a double. This is non-existent. So do we only have 3? No, I'm sorry, we don't. We don't. I can do this. If you want, you can count. It's still C6H14. All the carbon has 4 bonds. But obviously this looks very different from this one, and this one, and this one. It has 2 side groups. This is your longest chain. Again, this one doesn't matter if you go from left to right or right to left. Let's go from left to right. You have a side group here at position number 2, and here another side group at position number 3. We've seen this before, okay, where you have 2 methyl group in one chemical compound. In this case, this is what you're going to do. You're going to say 2 and 3. There's 2 methyl group. Okay. And this is a butane. Because there's only 4 carbons. Get it? Do you think we're done? I can show you one more. Watch this. Oh, yellow was bad. Let's not use that. Let's use purple. Watch this. C. Just C. No H's. Okay. I have one over here and one up here. this is actually different from everybody else. How do I know if this is different? Start to name it. Okay, once you start naming it and it doesn't look like the name that you got before, then you know you got something new. Left to right, because you want 2 to be the position. Okay, so in this case it'll be 2,2-dimethyl butane. Well, I don't have 2,2-dimethyl butane. I have a 2,3-dimethyl butane. Obviously, 2,3-dimethyl butane is not the same thing as 2,2-dimethyl butane. So I have actually 5 isomers for C6H14. That's ridiculous, but that's the truth. Okay, C6H14 has 6 different forms, and they all have different properties. They all react very, very differently. And there are going to be questions where I'm going to be asking you, hey, give me all the isomer for this compound. And your job is to list them out like what I did here. All right? Okay, are there any more? Is there another one? No, I don't think there's another one. But let me just show you some. Actually, you know what? Let's end it here. Let me give you some homework. I want you guys to start doing some of these things. Okay? I want you guys to start thinking about isomerism. I want you guys to do C7H16. I want you to tell me, how many isomers does this guy have? Try to catch them all and name them all. And we'll take it up tomorrow. How does that sound? All right, so C7H14. See if you guys can catch them all. Remember, if there are doubles, they don't count. In fact, maybe on a test, if I see double, I take off half a mark for every double or something like that. But yeah, so try to catch them all. I'll see you tomorrow.